All right, we are live. Man, I hope y'all are having a great start to your week. I had a fairly decent week last week. Fire school was a fun experience. So for those who just weren't aware, last week I didn't do a stream, and I was gone to fire school in College Station. It was actually a lot of fun. It was a very unique experience. I hadn't got to do something like that before, so it was kind of my first swing at it. Learned a ton. If you get into the fire service, especially here in Texas, Texas A&M, what they call TEX, TEX, is kind of the standard for getting into fire or fire training for the state, which they do I think like twice a year or something like that. I'm still I'm new to the whole firefighter thing, so I'm still learning a lot of that. But anyway, it's interesting stuff. It's fascinating to me how much of this stuff translates. So I was in a class for ag rescue. So basically, if you get stuck in a grain silo, or if you have a piece of equipment roll over on top of you, something like that, learning how we can use our equipment we use in the fire service to successfully and safely save somebody and not end up in a bad situation ourselves. And it's fascinating just how much translates. Especially like that ag rescue class, we just everything we do on a routine basis to lifting and like they were using gantry systems. That's what like gantry and rigging and chain falls, like all that same stuff was still involved and applied. Having to use safety harnesses and lifting, like it's so fascinating to walk into that and be like, oh, okay, well, done this for years, just different context. That's the only main difference. It's just a different context. That's yeah. It's just it. I love to see. This is what I love about HVAC as a broad category. It is so much of everything involved in one. Like I have yet to find another trade that we get to do so much inside of the same wheelhouse. Like we're not going outside of what we do in the industrial commercial side. When we get into the electrical work we do, the plumbing work we do, the mechanics we have, the chemistry we use with refrigerants, like guess like that is we're manipulating chemical components, right? That is a form of chemistry, in my opinion. Maybe there are some purists out there who might disagree with that a little bit, but um, in the rigging and the lifting aspect of it, there are each of these components that we do on a daily basis. There are individual industries committed to doing these things solely full time, but yet they don't have the cross training compatibility to put all of it together. And that's what I love about this so much is we get to take all of these aspects, all the trades I grew up knowing and I didn't know which one to pick from. Well, I found something I didn't have to choose. I just got to do it all anyway. It just in a very different way than I thought I would. So yeah. I hope you're having a great Monday. Hope you're having a great start to your week. Hope you had a wonderful weekend. We do have um, one question in the uh, the portal for on through the Chiller Questions Answered portal on chilleracademy.com. I'm playing with my settings here for the stream since I made some changes recently. I'm getting an alert. Let me try switching this. Let's see if that helps at all. Okay, I see y'all in here. Mechanical environments. I need to get some more shirts from y'all. We need to connect after this because I really enjoy y'all shirts. It's funny. I was at somewhere the other day, and a guy walks up to me and he goes, "You realize you got a weed picture on your shirt, right?" And I couldn't help but laugh. I was like, "Yes, I'm fully aware. There's a picture. There's a symbol there. Like, okay, I thought I'd ask." It's like, yeah, as if I didn't realize what that was. No, it's one of my students. I really enjoy working with these guys. They've done great work. So I'd love to get some more of your t-shirts, by the way. And if anybody doesn't have one, I'm telling you, these guys are pretty cool. You'll ought to check them out. Anywho, All right, so we got the setting adjusted. We are looking good on my stats here. Hopefully this will be a little smoother. And let's see. Yeah, let's move into our first question. So, what does low flow on the evaporator side of the chiller mean? So, low flow could be a couple of different things. In terms of what does it mean specifically on its own? So, by low flow, we're saying that we're low on GPM. Okay, so low GPM is the overall point we're trying to get to. So it's gallons per minute. Now, this could be a handful of different conditions. Okay, one could be that the pump itself is wrong. Maybe it's having issues. Maybe there's a impeller issue. So just the pump by itself has a number of things that we could be dealing with. We're talking strainers. All right, so let me kind of section this off. So we could have a strainer, and it may not be just strictly a pump strainer. It could be a strainer for the actual chiller itself. You may have both in some situations where the pump has an inlet strainer. You also have a strainer at the chiller. At a bare minimum, your pump will have a strainer in it, and this will be one likely source. You could have a flow setter issue. So the flow setter might not be allowing enough flow through it. It could be, say, calibrated to lower the GPM at some point. Somebody may have adjusted it for whatever reason. I've seen this practice before where they were actually having a mechanical and electrical issue with the motor and pump, and it was causing high amperage. But instead of addressing the actual mechanical problem, which was adding load, they ended up just adjusting the flow setter down to reduce flow, which that process reduces the load on the motor, and they reduce the RLA that way instead. Well, what that did later on is that ended up causing additional flow issues on the chiller itself, because the symptom was the high current of the mechanical problem. It wasn't the flow setter was open too much, allowing too much flow through. So those are some things we have to be careful of, but that's why we shouldn't just take things for face value in the field. Always try to verify, always try to experiment, because you don't know what other people have done or why they did it. They may have had a very legitimate reason at the time. In that particular case, they needed to have that pump rebuilt, and they needed to have some work done on the motor. It was by lowering the flow and getting that RLA down, because they reduced the load through the impeller, they did end up buying time. Okay, so that allowed time to get everything else resolved or get everything prepped, and it kept the chiller and the system online, which needs to be our ultimate goal. So that is one caveat I want to put in there, is just these are things that we should consider. Okay, so we could have a strainer, could have a flow, we could have an impeller issue. Okay, so if the impeller has damage on it, I've told this story before. We've worked on a system where the actual strainers, this was a very old plant, just came apart, and in that process it damaged the impellers. We could also have an issue where this loop has had low water volume for some time, or something was causing a major cavitation in the pump itself. That cavitation will cause a major erosion on our impeller. And so those are some aspects that could wear the impeller down, but then impeller damage could lead to lower flow output, even though everything else technically looks okay. So, and then it could be just a staging issue from a pump perspective. All right. So if we've got multiple chillers that we need to have online, and we're supposed to bring on more pumps into a common header, so we're not using a primary secondary type of system, but we're using a headered type of loop, then if we're not bringing on additional pumps with the additional chillers to accommodate the extra flow we require, then we could have a staging issue on our pumps, and the pumps aren't staging in unison with the chillers. So these things can cause low GPM conditions. Let's see. We could also run into a situation where we've got let's see. I'm trying to think through what else we could run into. The pump issues, the strainer, flow setter problem, impeller problem, staging problem. So let's cover the core question real quick. So what does low flow on the evaporator side of the chiller mean? It means that we're just not pushing the volume of GPM that we need to. It's going to result in low pressure issues. It won't be necessarily high approach issues, right? So because not enough water is flowing through the evaporator, so that would mean that we end up having a lot more contact time with the evaporator. That additional contact time is going to help lower our approach. So you would see a really good approach value with a low flow situation. It's when you're getting into a higher GPM state that you're going to see that approach start to increase. But even though your approach is low with a low flow, you will end up having low saturations. So your saturations are going to drop because you're not pushing as much heat through that evaporator. You're also not going to see the chiller stage up. So if you end up having a situation where technically the chiller's making set point, so here, let's draw this out. So the chiller could be making set point, all right? So we've got our evaporator. Okay, we're gonna be coming out, coming in. We've got our evaporator. We may have, 45 degrees here, but then as the chiller runs, this may go from 55 to then 60 to then 65, and we're losing the load control of it. And we see that because this number is steadily going up even though we're maintaining our leaving water. And our compressor is not really staging up all that much. It may make minor increments, but according to our entering water, we should be really staging up into a fully loaded state, but we're not seeing that on our leaving water side. This would be an example of a potential low flow issue because the water is having so much contact time that we can achieve set point even though our actual load is not being satisfied. So this would be another, say, symptom we could expect if we have a flow concern, like if we're having a low flow problem. At that point, if we just increase our GPM through the machine, however that would be needed, then we would start to see the compressor stage, right? So those would be the three main things. We're at set point, we have a high entering water, but our chiller is not staging up, and we don't have any limits, right? So in this particular scenario, you may not have a suction pressure limit. You may not have a high pressure limit or a current limit. None of those limits are existing. The chiller's just making set point. There's nothing else preventing it from staging up if it wanted to or if it thought it needed to. But because this is at set point, it's not going to do anything else. Again, flow. This would be a prime example of what you would see low flow result in. Low flow could also be a actual water volume issue. So if we have a just low water volume, okay, that means that the loop does not physically have enough water in it. It's just, for whatever reason, we've lost it somewhere, something has happened, there's just not enough water there. That will end up resulting in lower total GPM through the system. And we're going to see this at our pump pressures especially. Now you'll also see this on your DPs and stuff, right? So this whole time, our DP on the chiller side, on the evaporator, is going to be fairly low, right? So lower DP on the evap means less GPM through it. there is some caveats here around if you have plugged tubes. That's typically not the issue, even though that does happen. It absolutely happens. We cannot ignore that. But from a general sense, on most calls you're probably going to go on, lower DP, P, not B, is going to equal low GPM. So if we want to increase GPM, we need to increase our DP. We need to push more water at the chiller to get this higher. Again, caveat on plugged tubes are going to affect this heavily. So if we got some tubes that we can't flow through, maybe they've been intentionally plugged due to leak issues, stuff like that. Eddy current test failed it, something along those lines. There are reasons that we would have plugged tubes legitimately, but we need to get this up. Well, if our water volume is too low, then we're not going to be able to push enough water through here. We're probably going to see cavitation issues or somewhere close to that. There is a reality where you could be just above cavitation, so you may not actually hear it in your pump assembly, but you're not actually flowing enough water. You don't have enough water in the loop to flow properly in order to push enough volume through the chiller itself. So the total volume of water could be another issue. So I think that would be a quick summary, if you will, of things that when I say we have low flow on the evaporator side, this is what that low flow is meaning. And those are some conditions or symptoms I would be looking for if I was on site trying to determine what our issue was at the time. Yeah, good question. All right. That was our main question we had in the portal today. So that is the Chiller Questions Answered portal at chilleracademy.com. I do try to prioritize those. Last several weeks with the floods here have been really chaotic for me. So I haven't kept it as up to date, but I've been working on over the weekend getting that back up to date and keeping this rolling going forward. This life hopefully gets a little less chaotic for me. Why does a York ramp open randomly without process change? We have to go to the field display and manually walk guide vanes closed, and then it controls like it should. So, Hubert, is the when that's happening, do you see the leaving water? Does the leaving water start to dramatically go down? As in, so your leaving water temperature, does it take a nosedive with it and the chiller is no longer responding to set point? What is happening on your leaving water side when this happens? That's going to be a key indicator as to what direction we should go with that. I can answer the question in either direction, but it would really help focus the answer with that little bit extra detail. You got no water. How you doing, Froggy? Mr. Eric, I see you in here. Would you come to South Fort Worth to look at a process chiller with me? Repco with bits or screws. So, Eric, right now my in-person stuff is really heavily booked. There are some potential appointments that are, call them, shaky at the moment, just due to different circumstances with the job sites. So I'm going to have to see how those play out and what we're going to do. There is a potential that maybe come towards the end of August, I'll know what I'm going to have open up, if any at all, for this year. And I'll be sending out some invitations, because I've got a list of folks who are kind of on the, call it, backlog of wanting to get in-person help with things. So if you would, reach out to me via email and we can talk about that further, and I can see just how, like, what your conditions are on site, when you're looking at trying to get there and have that. I see their beaks. I really appreciate that, sir. Wow. Watching your channel inspired to get my EPA 608 and start. Awesome. Working on some York screw compressors with 134 in it. What do you think about them? Do you have any questions about those York screws, right? So I'm assuming you're probably dealing with a YCIV or a YVAA, depending on how old the machines are. So yeah, any questions you have on that, feel free to send them out there. And congratulations, HVAC is an awesome career, especially if you stay focused on the commercial industrial side. So here's some really interesting facts I've been looking into, and I really want to push this a lot harder. So right now, HVAC on a global scale is about a $200 billion industry, and residential of that only makes up about 30% of the entire industry. And I've done this experiment with a lot of people. I did this at fire school a lot. When you think of HVAC, what's the first thing you think of from a job standpoint? You think of residential. Well, residential is only that 30% of the market, 20 to 30% variably. It's the commercial industrial that makes up that 70 to 80% of the rest of it. So there's just so much opportunity, and from the research I've done, we're about 43% short, meaning we need to increase our current. That's just for today's standards. That's not including what's coming, in terms of how many more people we need. We're lacking that much. What that also means is us as the technician, there is huge opportunity because we can step in and fulfill that need, and there's just the worry about competition is way lower. Okay, so to my knowledge, there's no change in process temps, levels, flows, or levels. Interesting. All right, so York chiller. One final question then, because my mind goes to potential surging. So you said is this a screw machine, Hubert, or a centrifugal? Because my gut says, based off of what you're saying, my gut says it's a centrifugal. At which point we'll dive into the surging aspect of it. I'm trying to think through from a screw perspective. Yeah, it is centrifugal. Okay, yeah, I had a feeling. Okay, I was really trying to rack my brain from a screw perspective what would cause that, but centrifugal, yeah, okay. Let's dive into that. All right, let me put that up here just so that everybody else has a clear view. Okay. All right. We'll cover this quickly. Oh, I need to split that a little more. All right. Why does a York chiller ramp open randomly without process change? We have to go to the field display and manually walk the guide vanes closed, and then it controls like it should. Now, I have confirmed that this is a centrifugal specifically, and we're not seeing any changes on the actual process side of this. So my thoughts go to a surge issue. So what I think is probably happening, especially being the YK, so we've got the surge map inside of the OptiView panel. So that's the field panel you're working with. It is very interesting to me that it's not increasing on, or it's not, the leaving water side is not decreasing, but my instincts would say that we've got a surging problem. So we're dealing with surge. And the reason for that is that chiller is monitoring it's going to be monitoring its surge conditions. So you're going to have an IGV at a bare minimum. So inlet guide, or let me talk this in York terms. I'm sorry. You're going to have a PRV. Okay, so we're going to talk York with likely a VSD. Now the VSD may be optional. You can tell me if you've got a VSD or a VGD. That doesn't really change things that much, but given what you said, just let me know in the comments if that's actually, if you have the VSD. At a bare minimum, let's just take this from a PRV perspective, because you mentioned that you're just having to lower the vanes down or close them down in order to get the machine to settle back out. Because part of what's going to happen is your current is going to increase. So if the machine is detecting a surge, then it's going to open well, hang on. Nope. As I'm saying that, it just caught me. It does have a VSD. Without process change, we have to go. Yeah, because as I'm starting to explain that, it hits me that I got that backwards in my head. No, with a surge, we're going to close the PRV, not open the PRV. So, okay, well, let's talk through this. This is a great example. This is something I've been wanting to do a lot more of. Let's take a situation and actually just talk through it. So, okay, so we have a VSD. We have a centrifugal. PRV is opening. Is the VSD... So the only way that makes sense to me, the VSD has to be slowing down. Do you know your current, your RLA, may not change much. That may stay relatively the same. But does your VSD hertz output slow down? Is that something y'all have checked for? Given the circumstance, I don't know that it would necessarily be like a default go look at. But have you actually gone to the motor screen and verified your VSD output during that time? Because part of what I'm thinking through is I wonder if it's trying to optimize for efficiency, and it will do that by, it'll slow the VSD down and it will open the PRVs. Now, part of what will happen is if you take manual control of the PRV and then begin to try and close that, well, the VSD will compensate, because it's still going to, even though you've got manual control of the PRV, the VSD is still going to try to maintain leaving water set point. So that would make complete sense, because haven't checked, usually happens off hours, no mechanic on site. So that would tell me after hours, lower load conditions, I would assume. You can correct me on that. Excuse me, on that. So there's going to be a lower load. The chillers should be able to ramp down. Okay, I think I see what's going on here then. All right, not a surge issue then. Let me go a different direction with it. I also get a better color. Okay, so what I think, get this open. What I think is happening is your machine is optimizing and it's doing what it's supposed to with this. So the PRV and the VSD work in unison together. And in a perfect world, we will run the PRV as open as possible. So full open, with the VSD as slow as possible. So slow. This is a perfect world, because at this point, our impeller is at its maximum mechanical efficiency when the IGVs are fully open, feeding into that impeller. But then our VSD is at its maximum efficiency when it's having to output the least amount of current possible, or in which we do that by lowering the hertz output to the motor. So this is an ideal position. And part of the staging of these chillers that you'll run into is the PRV. Stage 1, chiller turns on, PRVs are closed, and so we're going to go 0%, and you're going to have a minimum hertz, which is, if we're going with a 60 hertz machine, so I think, what is it, 30 hertz, I think? Okay, so this would be, say, your startup conditions. And then we want to start increasing load to meet leaving water set point. So then we will slowly work our PRV up to 100%. Okay, let's just say we don't have any surging concerns. And we will still maintain this 30 hertz right here if we can. We'll stay as close to it as we can. Yours may not be literally 30 hertz, just as an example. Let's just say that was our minimum hertz programmed in for your machine. The only reason we're going to increase hertz before we hit 100% or PRV is if we're having a lift concern. So if per our surge map or our stall sensor, if any of those are detecting a possible surge or stall condition, then what we will do is we'll pause increase in the PRV and we'll step up our hertz. So if we don't hit this, let's say we made it to 80% PRV. If I could write today, that'd be awesome. Let's say we made it to 80%. And then at 80%, we started to see some instability. So then we would end up seeing the hertz, say, increase to 35 hertz. Once we hit 35 hertz, we overcome that lift condition, and then we could increase a little bit higher and then make it to 100% IGV at 35 hertz. Now, if we hit this point with 100% IGV and 35 hertz, but we still haven't met leaving water set point, let's say we're at 47 degrees leaving water and we're trying to hit 45, then we will start to increase the hertz instead of the PRV. Now, this is a proper staging sequence, but depending on the circumstances, we may have a situation where we can't increase the PRV to 100% due to whatever load conditions, specifically lift conditions. Our lift may be in a position, and I'm covering up my thing here, aren't I? Our lift may be in a position to where we can't actually get the PRV that high, because if we did, we would go into a surge, and the chiller is monitoring this and it knows that, and it's not going to intentionally surge itself. So then we'll just see the speed increase. So what I would expect in your situation is your machine is operating exactly like it should, and that when it goes time to unload and run at a minimum state, you want to see that PRV go to 100%. And then you want to see that VSD modulate up and down. And when you're able to do that, you're allowing that chiller to run at its maximum efficiency it's capable of doing. And it's intentional. And that's why you don't see the leaving water set point fluctuate. Or not the set point, but the actual leaving water temperature. The leaving water temperature stays consistent. It's at set point, but the PRV is full open. This is why. This is a good thing. So I would encourage you, this may be a good test for today. Go look at your, in a normal operating state during the day when it's got load and it's having to deal with more lift issues because our condenser water is going to have more trouble getting down to temperature, like all those factors are going to be true. Go see what your speed is under those conditions. And then the next morning when y'all come in, because that's what it sounds like. It sounds like when you come in the mornings, you're seeing the PRV is running really high. So in that, then go see what your VSD is doing and see if maybe the VSD is lower. Maybe. Because part of what will happen is when we do deal with a high lift condition, the PRV will close and the VSD will speed up, which especially during this time of year, this is when we're going to deal with higher lift conditions because our condenser water typically is going to be increasing and we're going to have higher loads. Those things in unison could push our lift conditions higher, especially the condenser water aspect of it. So if we can get in the evenings when the condenser water drops down and our load reduces, we have a lower total lift, then that chiller may be able to run in a way that it can't run during normal operating hours. I'd love to hear a follow-up on this. And if you have any thoughts or if there's anything that might contradict kind of that standpoint, feel free to throw it in the chat so we can talk about it. But that would be my assessment if I saw those conditions. Sound good? Okay. Centrifugal VSD. Yeah, these new to chillers and contractors we use can't tell us what's going on. Oh, wait, that's okay. So, here's the problem with being third party, especially in today's age, right? We do not have the depth of training and knowledge that we used to have. In addition to that, it's made worse by the fact that we don't have. When you're a third party, you work on everything. Like you don't have a specific brand that you're married to. So that does become a little bit of a disadvantage compared to the factory because they're solely focused on this, but they come with those prices. They come with all their other caveats that a lot of customers just don't want to deal with. So not only are we having to learn a very large variety of different types of machines, we also just don't have the depth of knowledge and training and understanding of these machines that we used to have as a whole. And that's okay. This is something we can work forward with. And like for Beeks coming into the industry, like it's a huge opportunity for him and the rest of us, because as we can get better, work through and learn these things better, we're going to be able to capitalize on far greater opportunities for ourselves. So I'm glad you're getting into chillers, man. It is a wonderful side of our industry. So much of our major infrastructure runs off of this, as you see with the facility you're at. Data centers are a lot of our federal facilities. Like a lot of our huge major infrastructure, things that make our society function on a daily basis, run off of hydronics and chill water. And if those systems ever shut down, huge portions of our entire system shut down with them, right? It's a very serious work that we're doing, and I appreciate you taking it seriously and coming on here and trying to get those questions answered. It does matter. All right, can you share the reasons the York YK chiller with LC showing oil variable speed pump set point not achieved? Yeah. Let me get your question up here. All right. Bear with me just one second. Okay. Just so everybody's on the same page, you can see the question. Why does a York chiller... Wait, nope. That's not the right question. I just did that. What happened here? Did all that and wasn't even realizing. Come on. There we go. That's the right question. Okay. Now we're Cadillacing. Can you share the reasons for a York YK chiller with LCSSS showing oil variable speed pump set point not achieved? So with a YK, we have an oil screen. That oil screen is giving us our oil DP, right? So that DP is what we're functioning off of. And give me a second, and let's actually pull up an image of this. If you just bring me. And I want to actually show you. Wait for my drive to boot up here. Come on. All right, so what I'm doing is I'm going to pull up the actual screen so that you can see the oil sump screen and we can talk through it. Come on. My computer is not. Oh, okay, I see it now. All right. So this is the oil pump screen. So we'd go from home screen. Over here, you're going to have the oil sump screen. We get into this on your YK with your OptiView panel. What we're going to see here is our oil pressure, oil sump temp, saturated, and then you have your oil high pressure and low pressure. So this low pressure is going to be your actual sump pressure that's being registered where the oil reservoir is. And then our oil high pressure side is actually up on the back side of the compressor after our oil filter. So you're getting an alarm that you're not hitting set point. So you have a variable speed oil pump. We can see that here. So you have your oil pump drive output, and we have our set point. So we're trying to achieve 35 psid. And this particular pump is able to hit that set point, right? So oil pressure, psid right here, this pressure is responding to this set point, and it's using the high and low pressure difference, the psid. So we have psig, g, d, okay? So we will modulate this hertz output in order to achieve this set point right here, right between the set point and the oil pressure. This tells us that we have adequate flow through the machine or through the compressor in order to lubricate everything. So what's happening is this machine has, what is it, the first 30 to 60 seconds, it needs to be able to boot up, or before it turns the compressor on, mind you. So you'll tell the machine to turn on, and before the compressor actually starts, we have to hit this set point. And it doesn't have very long to do that. It should be able to do that relatively quickly. If it doesn't, then you get the set point not achieved alarm. So essentially what that is showing is that you've got a restriction somewhere. You've either got a restriction or you've got low oil volume. So either one of those could be causing that, where if the oil volume in the sump is low, then that low volume will lead to not enough oil flowing through, and you're going to see that on your oil level sight glasses. Okay, so if you're checking those should be within the green range on that sump assembly, and if they're not, that would be one step to proceed with. The second most common would be the oil filter assembly. So if the oil filter begins to plug up, it will not allow enough oil flow through it, and that will cause the same alarm. So that's one of the first steps. It's actually typically recommended is when you start to see that oil flow alarm, the first thing you want to do is go and verify or probably replace that oil filter as part of your service. And part of what you'll see is essentially you'll see that this is a 60 hertz pump. So you'll see this oil pump drive command frequency go up to 60. But even at 60 hertz, the oil pressure does not hit set point, which 35 is the default. Most machines like this run at about 35 psid, so that's about what you're going to be looking for. And maybe that's one issue. Maybe somebody increased this for some reason. I don't know why. Maybe there is a legitimate reason why they would have. There could have been previous issues with an overhaul and the oil ports. There may have been valid justification for it, but if it was able to achieve that at one time, I'd say it should be able to achieve that going forward. So let's say this was 40 psid for some reason. Well, we should still be able to see that up here, and I'm not saying that you should change it back to 35. There's a reason it was put to 40, I would assume. So let's be careful just changing it back. We don't want to tear up bearings, because that is the ultimate consequence if this is not managed correctly. Bearings get destroyed, we lose our compressor, and we need to do an overhaul. So yes, oil filter will cause this. If it gets plugged up, it's not going to allow enough flow through it in order to achieve set point. If it's not an oil level or an oil volume or oil filter issue, then we could be dealing with a bearing issue or an issue up in the reservoir inside the actual compressor itself. So it is possible that when the journal bearings are just wiped out and they can have so much oil volume through them that basically it's not able to allow the system to build up pressure, and that causes a oil pressure issue where you're not able to hit that set point. Now, you're talking a pretty severe condition at that point. Usually you would start having more symptoms than just that oil pressure, between noise, major vibration, things like that. That's what you would expect to start seeing leading up to that severe condition in a journal bearing. So I don't know how much history you have on this particular chiller, but that would be something I would be looking for is, okay, is the oil pressure, or do I have, when this chiller was able to run, were we having a lot of vibration issues? Was the compressor making a lot of additional noises, specifically like mechanical kind of wear or grinding noises? Those If you're worried about that, though, not to get too far off on the tangent, if it is a bearing issue and it's gotten that far, you will see that in your oil sump and your oil filter, especially the sump. So you would be able to take a small oil sample out the bottom of the sump, and you're going to see a lot of metal flakes, and specifically you're going to see aluminum flakes. Now, if you want to be able to differentiate between aluminum and steel, just take a magnet. If it's steel flakes you're seeing, they're going to magnetize. If it's aluminum, they're not going to be magnetic. And that's how you can differentiate. Do we have something going wrong that we're having, like steel shavings, which could be the oil pump itself, could be some other part of the housing making contact it's not supposed to. There's a tolerance out. So that would be steel. Most of the time, though, you're going to see aluminum. And that could either be your journal bearing or bearings, or it's going to be your impeller. Let's just hope it's not the impeller. I would much rather see the bearings be the cause of that. But those are going to be things you're looking for. So if you go ahead and do an oil filter service, replace that oil filter, you're going to see those shiny flakes and fragments. If you see that, the compressor's in trouble. Whatever the conditions may be that led up to it, it's time to do a overhaul, or at least a tear down investigation at a bare minimum, and inspect everything. So from your position, okay, hang on, before I summarize that, the only other thing would be an issue with the pump itself. So if the pump itself is not making enough flow. So the pump, it may be getting up to 60 hertz on the motor, but something has happened to the gears, because it's a gear style pump. Something has happened in there and it's not able to move enough volume through it. That can that'll cause a similar issue. So you may have a pump issue. So to summarize this though, my first steps would be, one, verify I have enough oil in the reservoir, in the sump. If I do, then I'm going to do an oil filter change. I could take an oil pressure differential across the filter if I wanted to. So those filters have an inlet and outlet valve. You can take a pressure reading right there, or just take a pressure reading on the inlet of the filter and then use the chiller's high pressure reading right here. So you could take this pressure, then have a gauge on the inlet of the filter, compare those two. That would be one way to do that, even though it's better to use the same calibrated gauge when possible in order to try to compare a DP like that. Either way, so you could do that if you wanted to. I don't know that I would feel a need to in this circumstance, but if you saw a significant pressure drop, we're talking a few PSID or more across that oil filter, then you know for a fact that filter is restricting flow to a point where it's causing a big part of your problem. So in servicing that oil filter, you're going to see a lot. You're going to see the flakes. It could just be a routine change, right? So some people, York has changed their recommendations on those oil filters over time. They used to recommend it annually. Then I think it was every like 3 to 5 years. Now, my understanding is their most recent recommendations are just as needed. If their filter is not showing any symptoms, you're not having any problems with flow, then just let it stay in service until symptoms actually present themselves. Then go through the process of servicing that filter. So that would be this could be just a normal routine. You might change the filter. You could inspect the filter and really not see anything wrong with it. You may not have metal shavings. You may not have anything else. Maybe it's time to change the oil. The oil does need to be changed after so many run hours. It will start to get very dark in color and tint. It'll start to be far more liquidy. It won't be as thick. It'll be a lot thinner than it would be if it was new. That's part of what happens as the oil breaks down. So maybe doing an oil change would be a recommended procedure at that point, in addition to the oil filter. I would start there. If my oil filter showed those flakes, then we just need to stop, and it's time to consider doing a teardown and investigate the compressor. If I don't have those flakes, the metal flakes in the filter or in the sump, then I'm just going to service it and see how it performs. And I'm going to be very conscious of the fact of when it starts up, am I noticing excessive vibration? Does the oil pump have to still ramp up to high hertz? Because in my experience, most of the time, this pump assembly, this hertz, only needs to run, say, between 30 to 45, 50 hertz, and I would consider that very normal. It's when I start to have to push over 50 hertz especially that I started having to ask more questions of, okay, well, why is the pump running that high? Because most of the time, it doesn't need to run that high on these variable speeds. It just doesn't. So if I'm seeing that even after doing, say, an oil change and a oil filter change, then we're kind of back to where we started with, is it a bearing issue? Is it a pump issue? Which direction do we need to go with that from there? Either way, that's how I would approach that situation and what I would want to see to move forward. Okay. So, anybody has any questions, feel free to get them in here. I do have some in the backlog. If we want to get to those at some point, but I want to make sure I get everybody's questions here live. Excuse me. So, if anybody has anything, please, get it in the chat. Let's talk about it. I say we got a handful of younger guys, and even Eric. If you wanted to kind of throw some details into what you're dealing with, maybe we can spend some time discussing it while we're here. We got some more time. I'll go till probably we've got another 30 minutes to an hour. I can commit. The oil filter has been changed, and new oil has also been changed. Now, what the chiller does is when it's switched on, the oil in both the sight glasses just disappears, and it shows the error and shuts down. So, with that, I would. So, how high in the sight glass is it? Because typically that oil level will drop about I'd say probably about 2 inches or so when the pump comes on versus off. So if it only has just a little bit of level above the sight glass, every time that pump turns on, it's going to drop below that. Now, if it's still that close, I would expect it to still be able to make pressure. So yeah, if it's close enough that you're above the sight glasses when it's off, you should have enough oil in there to be able to make pressure in the first place. That would be my assessment. So if you've got a new filter and new oil, well, then we get back to the original conversation. One, did you verify any kind of metal flakes in the old oil or filter? Is that oil pressure transducers? Are both of those reading correctly? So I didn't think about that a minute ago, but that could be something we need to verify. Is there an issue with those transducers? If those transducers are not reading correctly, then that could cause a similar issue or the same issue, and not actually be a oil pump problem. And if memory serves, so both of those transducers are on service valves. So this is something to be careful with. Make sure both of those service valves are open, because those transducers are made to be replaced without having to recover the whole machine. You still have to shut it down, but you don't have to recover it. You can just close, or it would front seat those valves in particular. You can actually see that here behind me, right there, right above the panel. That is where the high pressure transducer is. So making sure that the valves are open. Both of them are back seated on the sump pressure and the high pressure. That's going to be an important step, just to make sure you're seeing pressure to begin with, or are those pressures changing? When the pump is off, the lower sight glass is full and the upper sight glass is half. And as soon as it's switched on, both sight glasses are cleared. And then after the pump shuts off, does the oil level come back? So that would be my next question. Do you see the oil level come back up after the pump shuts off? I'm trying to think through that. That is strange that it would fluctuate that heavily, that you're seeing oil level in the upper sight glass, but yet it's draining both. So that goes back to, okay, so at that point, that goes back to the concern about the journal bearings. So the journal bearings have to provide resistance. Yes, both transducers were changed as well, replacing the oil filter. No metal shavings were there. That's interesting. Given what you're saying, I would have really expected there to be something. Okay, let's pull up. Let's keep chasing this. This is a really good chat. Yes, oil level comes back when the pump is off. Okay, here's what my instincts say. Let me pull up a compressor diagram and let's talk through that and kind of explain what I'm thinking. Let me find the diagram I'm looking for. Yeah, let's get this one. Okay. So, oops. Control Z. A couple of things could be happening here. All right, so our pump is coming out. We're going through the cooler, through the filter, coming back up. Your high pressure transducer is up here reading off of these lines, right? So you can see how it's ported. This is the reservoir. This reservoir should be filling up. You've got a slight weep hole up here that it is able to bleed over through, and then we're pressurizing this chamber. So this chamber is here to make sure that we keep enough oil that if we have a shutdown, we have enough oil here to maintain the journal bearings during the coast down phase, right? That's what this whole reservoir up here is for. So every time we, that's why we have to do the pre-circulation of the oil pump. We want to fill this chamber and we want to verify that we have oil flow before we ever bring this online, because we don't want this metal shaft to ride on this journal bearing right here. So you've got 4 journal bearings on this compressor. You've got one here, 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 and here. So part of what I think you're dealing with is, unless something has, well, you've confirmed that the transducers, yeah, so if the transducers are fluctuating in pressure, so I would assume that these service valves are not plugged up either. So what I think you may be dealing with is when these journal bearings begin to fail, what can happen is this chamber up here and this assembly can't pressurize properly because the bearings are allowing a excessive amount of leakage out of them, because part of that is normal for them. As they're running, the oil is pushing out where the shaft is, which is intentional. That's part of how we lubricate our helical gears. So the oil is pushing out in here and is falling into the bottom of this of the compressor housing, and that's where it drains back into our sump. So what I think may be happening to you is this pump comes on and it's pushing everything up. It's trying to fill this chamber, but I think your bearings may be having an issue. And because they're having an issue, you're not building pressure on the journals, and all of that excess oil is coming into here. Now it takes a minute. Here's the thing. It takes a minute to fill this chamber, pressurize this assembly, for all of that oil to drain back down and to get into this lower cavity to then drain back into the sump. Which your oil circulations, like, what's very likely happening is that you're triggering the oil pressure safety before you can even see this oil start to return to the sump. And the problem comes back to, if these bearings are shot, which it sounds like they might be, you're not going to be able to build adequate pressure, especially within the safety time limit. So I think that's why you're seeing a high volume of oil get drained from the sump. Is moving a lot of oil up here trying to hit set point, but then it can't hit the set point, and it trips on the safety before that large volume of oil is able to flow back into your sump assembly. I think that is what you're dealing with, especially if we've got fresh oil and fresh filter. And the reason I'm not questioning the pump at the moment is because the pump is clearly able to pump enough that you're able to drain those sight glasses. Like, it's a lot of oil volume that you're moving all at once. So, and the fact that the oil comes back when the pump shuts off tells me that the oil's not getting sent somewhere else. It's not migrating. It's not pushing out somewhere else. It's just coming back into the sump. So it's staying inside of this this cycle here, the oil cycle that you see in this diagram. Like, all of that is happening. The only thing that I'm aware of that you're going to run into then is going to be these journal bearings. I'm sorry to tell you this, but I think you might be looking at doing a teardown. Yeah, I think you're looking at doing a teardown. If this pump had an issue, I wouldn't expect it to move that large of a volume. It wouldn't be able to move it that fast. So, yeah. Yeah. That's a tough one, man. I wish I had a better news, but that being true, like, let's say I'm correct. That compressor is not going to turn on until it's been overhauled. Those bearings are gone. That's just, there's not an alternative. And you've taken the right steps. Like, you've done what I talked about. Is these will be my first steps. You've done that part. Now you're into worst case scenario. I'm really glad you brought it up, though. Like, this is really good conversations. These are very challenging issues. These are advanced machines. I appreciate you trying to come in and at least talk it out and take the time. Yeah, that would be my recommendation. Is doing the journal bearings. Which, here's the thing: if you're going to go in and do an overhaul, it's way more than just journal bearings at that point. You've got like your labyrinth seal. You've got all of your different gaskets. You've got to think about your thrust bearings and your thrust collars, right? So there's a lot of other components involved in this that if you're gonna go to that process, it's going to be way more than that. Maybe you know that, but at a bare minimum, I think your failure point is the journal bearing. Is my point. Yes, to simplify the answer, not trying to complicate it. How's everybody doing? This chair I have constantly like sinks down. Something's wrong with the little valve in it. So every so often I've got to pick myself back up. Otherwise I sink to the floor. I do have time for more questions if anybody has any. This is a great time to just talk it out. And like I said, it doesn't have to be so focused on just like the chiller or the compressors. You know, part of this, the goal here is to discuss things around a chiller system as a whole, not just isolated to flange, you know, and that is a difficult thing that many of us fall into. Is you get caught up in the whole flange to flange mindset, meaning between your evaporator flanges and condenser water flanges, that you just whatever's the chiller itself without really considering the plant as a whole. But actually the goal I want to have with this Q&A process is whether it be the chiller equipment itself, the hydronic loop, the pumps, the plant as a whole, the control systems, the BMS, or cooling towers, like anything along, all of that is fair game, right? Or if you even if you have just basic refrigeration questions, right? I'm trying to make it clear that this is an open space to discuss chiller systems as a whole, and we deal with refrigerants. And so I've had to answer some of those questions before of just what does saturation mean? Like and I'm okay with answering that question. So I don't want anybody to feel like they have to have these big existential questions in order to engage in the chat here. No, this is a very open platform. I don't care how much experience you do or don't have. I want to be able to have open discussions, and I want to be able to answer your questions fully as best I can, to my understanding, to my knowledge, because I think that's what I wish I had somebody to do for me early in my career. I wish I had that person to bounce questions off of in a way that I just didn't. I didn't have an opportunity like that, and so I really want to provide one because I know that it's needed severely. Noted. Thanks for the help. I think I might look at the oil filter assembly once again for shavings because yeah, I mean, I agree with you completely. Yeah, if that's why I'm shocked that you didn't see any shavings. Like they're going to be somewhere. The question is where. The problem now is if the original filter. So I've heard about this. I haven't personally experienced it. When I've had this issue, I've always experienced some fairly large shavings. But I've heard guys talk about that they end up having very, like the particles end up being so small that you can't really hardly tell. Like one experience I had a guy was telling me about that because it happened slowly over time and it wasn't like big major dramatic events that kept happening, like a huge surge event ends up putting a lot of thrust on the journals or on the bearings and forcing a hard contact. It was just little minor events over time. It still wore the bearings down, but it did it in a slow, gradual way. And that process ended up creating these little fine aluminum dust particles. And how they found it was they started taking little sections of the oil filter. Now, this was a time when the filters were a canister, or not canister, a cartridge style, where they were a cartridge insert. So they cut out a piece of the fabric, the filter fabric, and sent that in with their oil sample and had it analyzed. And that sample ended up showing a high concentration of aluminum in it. And that's how they figured out. But it ended up being a journal bearing issue. But again, it was because of how it happened. Now, from my experience, that's not that normal. Most of the time, it's more dramatic than that, and you will end up with significant shavings. But just from what others have explained to me and what they've experienced, I do know that those situations have happened. So if you don't have the original filter or oil where you could take a closer look at it or have it analyzed, it may be hard to find that. You may have, maybe you get fortunate and the new filter and the new oil, maybe it had something in it. I do agree with you on, you really want proof, right? If what I'm saying is true, you really want proof. I absolutely agree with wanting proof. This is a major diagnosis to go off of no proof. And proof would be shavings, actually having the aluminum in the oil system. That is hard proof. I completely agree with you. Part of the struggle we're going to run into is at some point, we just have to look at our symptoms too. So just bear that in mind. There's only so many things that are going to cause the symptoms you have. You know? Like I said, as long the only caveat is I would have you verify, do your oil transducers fluctuate pressure when the pump turns on? Especially that high side transducer. That high pressure transducer up on the compressor should increase in pressure, even if just a little bit. It may not hit set point, but it should increase in pressure, period. If it is not, even if it is new and that valve is open, the port in the compressor itself could have gotten trash in it and it may not be reading correctly. It's still a pain in the butt to fix. You got to pull that valve out, which means recovering the whole machine, and you've got to try to clear out whatever debris got in there. So it's still a pain to deal with. But that would be the only other alternative that I could offer, is maybe that valve has an issue. And it's not necessarily the transducer itself. Okay, Mr. Brad, why would low oil in an RTAA cause low refrigerant temperature alarms? Low oil cause low refrigerant temperature alarms. RTAA. Because we need oil to load the machine, not unload. So it wouldn't be So how about this follow-up question? Brad, what conditions were you seeing? Can you give us some data from the machine that makes you think that the oil was causing low temperature? So I'm not saying you're wrong, but I'm trying to think through what conditions I would expect to see those two correlate. Because so low refrigerant temperature alarms, like there's a few things that I've seen cause that. The female unloader, how about this? Why don't we you can follow up in the chat. Let me just dive into it, and I'll start writing my thoughts out on the whiteboard. That way we can keep track of this. Oops. Okay. So just so we're all on the same page, why would low oil in an RTAA cause refrigerant temperature alarms? So if, like I said, if we can get a little more detail on the parameters that led us to that conclusion. So basically I have gone through the entire machine, couldn't find any issues. I've watched your videos, and that is what you determined. Okay. I'm glad you brought this up. I made a mistake in, if you're talking about the video that I'm thinking of, that I did find low oil, and I did suspect that causing a low refrigerant temperature issue, but I later found another problem, and if memory serves, I think I did a follow-up video where I talked about it, and I was also explaining how the unloaders and the female unloader specifically was working. It's going off in the alarm only during load situations. Okay, hang on. Low. Does it do it at startup? So that would be my next question then. Is it only doing it at startup? Low load situations. I mean, part of that female unloader is there to help unload the machine. So let me, just for argument's sake, let me kind of go through some of the things I've found that will cause so we got a low ref temp. On an RTAA. All right, so some things that are common, the EXV. doesn't open, or at least doesn't open fast enough. All right, so EXV open is 1. Another one could be, a charge issue, so low charge, low flow. Now, this would be, so these two could be specific to a particular circuit. A low flow is going to have this issue on both circuits, I would expect. The thing is, it's very intermittent. Sometimes it runs for 2 to 5 days completely fine, and it randomly trips. Ooh, okay. This RTA doesn't have a sight glass below the EXV, unfortunately. Interesting. Are you sure it's not on the backside? I don't mean for that to be insulting in any way, but some of those EXVs, the sight glass is on the inside, not the outside. So if you're looking at, what is that circuit? It'd be circuit 1. No, circuit 2. Circuit 2 on the left-hand side, the sight glass is typically on the inside. So if you're looking at it from the outside of the chiller looking in, you're not going to see the sight glass sitting there. But it's also where it's at, though, is damn near impossible to see it to begin with, even if it is there. So I'm just putting that out there just in case. Anyway, so low flow we're going to see on both circuits simultaneously. We could have a female, we could just have a loader issue, right? Whether it be female, male loaders, or the slide valve. So we'll call it unloading issue, to summarize that. So that includes all 3 of the unloaders, or the slide valve itself could be having an issue that's allowing us to trip on low refrigerant temp. We could also be dealing with an oil log situation. Now, you're not dealing with oil logging, or at least we don't believe so, especially being the fact you're showing low oil level in the reservoir, but you've checked that during normal operation, and the oil, it seems like you found low oil levels, so oil logging is probably not very likely. From what you've described so far, my thoughts either go to unloader or EXV. The reason I'm honing in on the EXV, so what ended up being the case with that unloader or the oil issue, that I thought what was happening was the oil was causing a problem with my male loaders. And because the oil couldn't push the slide correctly, it was causing a problem where I wasn't unloading the way I needed to and allowing that slide to move back. So that was my initial thought, but then I later discovered that somebody had actually wired the female unloader to the 120 circuit at a hard wire. So the female unloader was not bypassing ever. And this was happening to me specifically at startup. It wasn't happening during operation. So I verified the cavity pressure inside the female unloader and the male load slide change when load and unload. The approaches are, so you've verified the unloaders. So that further makes me think of EXV. So here's one of the things I found with EXVs is when they begin to fail, they may have periods where they seem to work. And those EXVs are, they only calibrate when the chiller is powered cycled, or the circuit is, let's see, does it do it every time when the circuit is shut down and it's preparing to bring the circuit online? it's supposed to do a calibration, or at least it does that after a power cycle. For sure, it happens at a power cycle in the RTAA. I don't remember if it actually does that every time the circuit is commanded on or not. But what I find is that sometimes if the valve is early enough into the failure process, it may take a couple of days sometimes to get out of calibration enough to start causing issues because the valve is having trouble opening sufficiently. I see, verified the which the approach sounds good with 5 to 6 degrees. The ohms on the EXV are correct across all 3 windings. The EXV doesn't seem to pass the EXV test though. Seems like, yeah, so that's what I'm really thinking. Yeah, it seems like they're getting stuck possibly. So, which at that point, on these RTAAs specifically, I have had far more issues with those EXVs failing mechanically than electrically. Most of the time when these have gone bad on me, they're usually a mechanical failure. So there's a set of Teflon, I don't have one of those here with me. Here. Okay, so I have this one right here. This is out of a YCIV, not a RTAA. But there's a set of Teflon threads in here that are controlling this plunger. So this plunger slides in and out on those threads, and as the Teflon gets worn down over time, especially as the valve hits its end stops and the clutch in there has to spin, it ends up weakening that Teflon, and that Teflon begins to strip. And so that plunger will then try to move at times, but it slips a thread every so often. And every time that thread gets slipped, that valve gets further out of calibration. And so that's part of what we're looking for is when that valve gets far enough out of calibration, it could end up starving the evaporator, which may be what you're dealing with. The control panel thinks the valve is at maximum position. It's full open. It thinks that. But in reality, it may only be partially open. And it's because that plunger is slipping on a thread. And this could happen quickly. This could happen over time. Now, you should be able to hear this. So these valves, when they're in good condition, will be relatively quiet. And you'll feel it, and it will be a very smooth operation. It's not going to generate a lot of vibration in your hand. As the valve begins to wear down, specifically mechanically wear down, it gets louder audibly, and you can feel more of the vibration as it's trying to thread that plunger in and out. The pulses in your hand holding onto the valve get way stronger. So that's part of what you're going to be looking for in this scenario is how does it sound and how does it feel in my hand? Yeah, that would be the direction I would go with that. I think you're on the right track with suspecting that valve. And yeah, I'm just thinking through different scenarios if I need to correct anything in that. Yeah, I'm thinking that valve is probably having a mechanical issue, and it happening occasionally every 2 to 5 days makes a lot of sense. That's all the same conditions I'm used to facing every time I've had one prematurely, or let me rephrase that. I've caught it when it was still intermittent, because there's been some cases where I caught it and it was just extreme. That valve could barely move. It wasn't that it wasn't moving at all, but could barely move each time. but then you get it into an extreme condition. And see, here's part of the thing is it happens every 2 to 5 days. It shuts the chiller down, but as soon as that valve is able to calibrate, it's able to run good enough for a couple more days. And then it trips and shuts down again. And then just that process by itself is going to force a calibration on that valve, because you'll have to go through a reset process. It's going to do a calibration before it brings it back on the next time. And it starts from a good position. And then it comes back on, and then it takes time and it drifts back out of calibration again. All of those are valve symptoms, mechanical issues on the valve itself. Yeah. The opening sounds very rough. Opening compared to closing. Yes. Okay. Yes. I think you're on the right track with, yeah, once the chiller gets up and running, it's beautiful. Maintains superheat. Yeah. Right. Well, it maintains it while you're there, right? So and this is part of what you're going to notice is if you're not there for the drifting process, right? So you're not going to see it or be able to actively notice it as it, I've also noticed it runs very low. Yeah. So that low superheat, that could be that could be part of our, well, I don't know. These machines can run fairly low superheats to begin with. I think they can be set down to 4 degrees depending on the application. So I don't know what your superheat set point is, and if you're saying less, because I think they need a minimum of 2 degrees to stay above the safety trigger or the cutout. So the suction superheat or the low pressure superheat cutout, I think, is less than 2 degrees. So I wouldn't say the superheat being low like that for that particular series, it bothers me less. What you're probably going to see, though, is I would expect you to see high superheats and your saturations beginning to drop and your approach going higher. Yes, set at 4. Okay. So as it gets out of calibration, I would expect a high superheat, a high approach, and your saturation would obviously be dropping at that point. But the compressor is still trying to maintain leaving water set point. So as we starve the evaporator due to the valve issue, then we still have to ramp the compressor higher to try to force more cooling on the refrigerant that is getting in there, which is increasing our superheat and forcing a higher approach value, just because we're not feeding as much refrigerant into the evaporator to begin with, starving it, right? Yeah, I feel pretty confident given the chat. I think we both are agreeing we're going to lean really heavy on that EXV being our primary issue. I think it's a good call. Mr. Barry Young, also new to the chiller trade, and a chiller would routinely cut off, saying evaporator low flow. This is a train chiller. Please explain. And is there any books for beginners on train? So, oh, Brad, hang on before I die. So, have I ever messed with the EXV control response? No, I've not had to manipulate any of that before. Yeah, I've just not found it needed. That's just me personally. If you ask the factory guy that, he may have a different opinion. I'm sure they've dealt with that a lot deeper than I have. But from my perspective, I've never had to touch that. So let's get into Barry's question here. And Barry, I did see, so at the very beginning of the stream, I'll kind of talk through some of it more here. But I did get into your question on the portal. So just later on when you get time, feel free to circle back around. That was the very first question I got to in the stream today. Just my point in saying that is just to give you a heads up that I did see your question and we did discuss it. Okay. All right. So I'm new to the chiller trade, and a chiller would routinely cut off saying evaporator low flow. This is a Trane chiller. Please explain. And is there any books for beginners on Trane? So in terms of the books, let me answer that first. The Trane IOMs are the best I could really offer right now. Those are going to tell you the most, and each model is going to have their own IOM. There's not a independent book outside of that. Now, Trane does have a PowerPoint type of presentation, and Barry, you're in the academy. I think I've got that one of the downloadable links. If you go into the certification course, at the very beginning of the course, there's going to be a section on study material, and there's going to be a module or in that module, there's going to be a lesson in there for Trane. I'm pretty confident I have the presentation or the slides that Trane kind of takes you through to explain some of this thing, and they're obviously going to take a heavy kind of Trane focus in what they're describing and breaking down. So just keep that in mind. That is actually a really good place to start with, and you can also get some of those other IOMs in there and just kind of read through them. Those are some very good, very basic ones to get started with for just reading material in general. And yeah, the IOMs are by far one of the best options we have. Now, in terms of the low flow, let's come over here. So flow could be something, move that out the way. It could be something going on at the pump level. So if we're having a pump issue, and I explained this deeper earlier on in the stream, but yeah, so strainers, the total water volume, maybe the flow setter issue, something along those lines. But specifically with what you're dealing with, you may be having I'm assuming you've probably got an electronic flow sensor. Maybe that sensor is having issues. So which Trane is using just kind of a generic one that's not specific to Trane. But they've just got a probe, and that probe feeds back into this little control module in the main control panel. So whether it be that module, whether it be the actual probe itself, because they're just using a temperature dispersion style of electronic flow sensors for their machines. And so that would be my assessment is most of the machines nowadays have those electronic versions. Now, granted, you could have a paddle switch version. So either way, paddle switch or that flow sensor, that would be where I would want to start is, are those having trouble, and what is my DP across the evaporator to begin with? Let's see. I talk about this. So in my service training program in the academy, I do have a lesson in there where I talk about being able to determine your DP that you need based off of just kind of some rules of thumbs, right? And the reason I take that approach is this is saying you don't have the factory data. If you have the factory submittal, you should know what your DP is based off of that submittal. If you can get that submittal, that is the best thing. It's going to give you what your evaporator and condenser DPs should be. So if you have the proper DP across there, then I wouldn't be worried about the pump so much, or flow, or water volume, or any of those things. I would be far more focused on the flow sensor itself. In when the chiller comes online, if it will. So the chiller routinely cuts off saying, okay, so it is online, and it sometimes these sensors just need calibrated. They'll drift out of calibration. They need to be recalibrated. Now, before you change the pot to adjust the flow setting on the sensor itself, you have to make sure that your DP and whatnot has already been verified to begin with. And I do find that a lot of people they don't calibrate these. They just leave them out the box as they are, and they don't actually get the flow right on the chiller and then tune the flow sensor to that flow. They just let it go. They do similar to a common practice we have with paddle switches, and I'm guilty of this too. How often do we actually calibrate a paddle switch? Most of us would say not very often. It's usually because it's a far more of a pain to do that. Flow sensors aren't so big a deal to calibrate, and the version Trane is using is calibratable based off of that little controller in there. And I could pull up a picture of that if you wanted me to show that, but I don't think it's really necessary in the moment. That would be, so this would be my first stop, and then verifying something like the approach value. Now, the approach value with a low flow issue is going to be less useful, strictly because low flow is going to lower your approach, which if you've already got good heat exchange happening, that's not going to do a whole lot for you. Something you could see though is, well, even that, I wouldn't expect. I just wouldn't expect that. So unless the chiller has a strainer coming into the chiller, maybe you could have a strainer issue on the inlet feed. Oh, I didn't finish my thoughts on. There's that ADHD kicking in. With a lot of these chillers, you can generally estimate the DP based off of how many passes it is. And a very, very loose rule of thumb, if you have no submittal data to go off of, is 2 to 4 PSID per pass. Okay? And my procedure in the service training program, this is what we go with. This is not a commissioning type of value. This is I just need to see if I'm even in the ballpark. And this is only really applicable to smaller machines. When you start scaling into larger machines, this changes entirely. But you're also dealing with a completely different market at that point. So having the submittal data should be far less of an issue with that level of client, in my opinion, or my experience. But when you're dealing with these smaller machines, it's very common that you may not have a lot of that documentation on hand. So using a 2 to 4 PSID per pass, so if you've got a 2-pass machine, then we could very well expect anywhere from 4 to 8 PSID over that evaporator. So if you're running 3 or 4 PSID on that CVH, and you said Trane, Centrifugal, or I guess you say just Trane chiller. So I guess in my head I'm thinking of a CV series of some kind. Either way, whether you're dealing with a CV or dealing with a air cooled, all the more modern machines at least have moved to the flow sensors. But the same rules apply whether you're dealing with air cooled or water cooled. That's not really changing anything, but the air cooleds do typically have the flow data. It's far easier to get your hands on than the CV series is, because the CVs are specific built to the site, and you'll have to get that actual design data, where most of the air cooleds are just kind of standard package built. There's nothing really fancy or special about them. They just stamp them out, ship them out, kind of thing, most of the time. Anyway, so yeah, this would be what I'm looking for in terms of if I am in this ballpark, then I would expect my flow sensor to register flow. Okay. Now, here's something else I want to get into. This becomes a much more existential problem. Being the fact that it is cutting off after it's already been online would communicate to me that there may be something else happening somewhere in the plant, whether it be a bypass or pump staging or I guess those would be the two big ones that come to mind. Bypass or maybe staging on the pumps, something along those lines. Something that, so if I, with the flow sensor being out of calibration, I would expect that to happen fairly consistently and quickly, right? So, and it's possible that if that flow sensor is just, it's showing it's just barely got enough flow, even though you technically do have adequate flow, but according to the sensor, you don't, then you might end up having just minor fluctuations in the flow and you just tip over that edge just a little too far, right? That's possible. I think far less likely. I think what's more likely is there's something in the plant changing. Maybe you've even got variable speed pumps. So the loop is looking at pump DP or the loop DP and then modulating pump flow based off of that, which will change flow characteristics at the chiller level. And maybe the PID controlling that loop pressure maybe it's not tuned correctly, or the limits of minimum and maximum aren't set where they need to be. Maybe that minimum needs to be increased. So on the plant level, there could be several things that are causing you to push into a low flow condition. And the chiller tripping on low flow is the symptom of the plant trying to optimize efficiency. Because that's the whole point of like whether it be a bypass valve or whether it be variable speed pumps, either direction you go with it, the whole point of that process is to optimize efficiency. And if we're not seeing enough flow, then maybe some of those limits on the automation side need to be adjusted so that we protect how much DP we have through the chiller. Yeah, this explanation kind of builds off of that very first question a bit and goes deeper, knowing that you are dealing with a train specifically. So we got a little more information here than what was posted in the portal, which is fine. But having that extra information, this is how I would say update my recommendation, or what I'm thinking of, what I would want to check and verify in the process I would want to go through if I was troubleshooting this at one of my sites. Yeah, just on a broad scale. Either flow sensor or the plant automation is adjusting. It would specifically be when the load reduces on the loop. So when we start having lower load conditions, it starts backing off on the flow, which eventually pushes the chiller past its trip point. Yeah, that's what I would verify. That would be my process there. Okay. All right. Get a stepper motor opening. Listen. Got be quiet. Get long screwdriver to ear. Yeah, kind of like an oscilloscope, or not an oscilloscope. Oh, the old lung heart doctor thing. A stethoscope. That's the word. Like a stethoscope. It's surprising how useful something like a stethoscope can be in this industry. Like, fascinating tool you'd never think. Um, anyway, okay. Well, I hope y'all enjoyed this. MTT, everybody. Make the time for your family, for your spouse, for your kids. We are in the thick of busy season. It is a difficult time. We've got to be making the time for our family. And if we don't, the time's not going to be there. Okay. And keep in mind, like if we're used to seasonal cycles and you go heavy and hard in the summer and you're making that time in the off season, I'm not speaking against that. Okay. That's a structure that works well for your family. My point is, let's really make sure that we are finding a time in a season to take that time and make that time with them and for them. It's just really, really important. They need us, and we're just doing our best to be out here and provide and take care of them. At the same time, I think for most of us, our families wouldn't, if they had the choice, they wouldn't sacrifice all of our time just to have more things at home. I believe that to be true. Granted, you get into teenager years and stuff, and maybe some of that shifts around a bit, but please make that time and stay safe out there. And yeah, Barry, it can be a complicated thing. So Barry, if you want to follow up, whether it be in the chiller community, in the academy, or send me an email or something, we can discuss that further. And if you want to share some of what you're seeing on site and like what your DP is and like just what are your on-site conditions, maybe I can help you talk through some of that a little bit better and get more specific. But yeah, it is a lot. So take your time, and it's okay if you feel overwhelmed. These can be complicated things to work through. So it is a difficult problem to solve. Period. Anyway, I appreciate everybody. Have an amazing week.